Hi everyone, Mr. Eric Kwa here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Okay, so for this question, right, it is a little bit you have to think and apply what you learn in VSEPR. So let's look at this question. Halogens form many interhalogen compounds such as ClF3 and BrCl. Central atom in ClF3, right, is surrounded by 5 pairs of electrons arranged in a trigonal bipyramidal shape. So they've shown you a default in figure 1.1. 3 different molecular arrangements are possible. Draw clear diagrams of this arrangement, each showing 5 pairs of electrons. 3 bond pairs to fluorine and 2 lone pairs. Okay, so basically I have given you a hint in the question already. The original question I don't think have this. So you must know that chlorine is your central atom, and then it forms 3 bond pair and 2 lone pair. So you got to rearrange yourself. Firstly, right, you got to know that there's 2 axial position. Okay, there's 2 axial position and there is 3 planar position. Okay, so the axial position, right, you can let it both be lone pairs. So then we'll come up with a structure like this. Lone pairs, and then you have the 3 then you have this, the 3 bond pairs. Okay, so this will be one arrangement, and then the other 2 arrangement, then you will toggle the position. So one on the axial, one on the planar, and then the last position you will be both your lone pair on the planar position. Okay, so you come up with these 3 structures. Okay, so this you can see is both on the planar, position. Okay, both lone pair, lone pair. Then this is lone pair, both on axial position. So one lone pair on axial position, one lone pair on planar position. Okay, so there's 3 different variations. They want you to state which one will result in a molecule with no dipole moment. Okay, so look at each one carefully. The one that will contribute to dipole moment, right? Let me just list it out. So this has a dipole moment individually like this. The net dipole, right? Because these 2 will cancel out. These 2 will cancel out. The net dipole is simply pointing to the left. So there is a net dipole here. One arrangement 1 is not the answer. Arrangement 2 will be the answer because these 3 dipole moments, right, will just nice cancel each other out. Okay, will just nice cancel each other out. Alright, so that is why number 2 is the answer, has no net dipole moment. Okay, the last one, if you put down the dipole moment, right, look at it, they don't cancel out. Okay, they don't cancel out. I'm not really sure what is the eventual dipole moment. I would think that you probably be pointing somewhere here. This will be the net dipole moment. Okay, in any case, we just need to make sure that the dipole moments do not cancel out. Then as long as they have a net dipole moment, that's not the answer. Okay, so part B of this question wants you to apply the principles of VSEPR to discuss relative stability. Okay, so VSEPR, the main thing, right, is that they want to minimize the repulsion. And then the second principle is they want to minimize the repulsion between lone pair and lone pair. Okay, that is the main idea behind VSEPR. So if you look at the 3 different arrangement, right, what we want to do is we want to minimize the lone pair to lone pair repulsion. So this lone pair to lone pair repulsion at 90 degrees is the most unstable for arrangement tree. Okay, arrangement tree. If you cannot remember, arrangement tree is the last one over there. Yeah, this last one is the most unstable. Okay, so if you compare the first and the second arrangement, right? Arrangement 2 will be less stable because there is a greater number of lone pair to bond pair at 90 degrees. Okay, so instead of 4 of them, you now have 6 of them. So arrangement 2 is very unstable. So this is the reason why we will take this arrangement as part of the shapes for our VSEPR for 2 lone pair and 3 bond pair. Okay, so this should actually give you a hint because if you actually studied VSEPR, you will know that this is the official shape for your 2 lone pair and 3 bond pair. Okay, so that will give you a hint that this should be the most stable. This should be the most stable arrangement for 2 lone pair and 3 bond pair.